All right, so let's talk about different ways on how to solve quadratic equations. So the most popular, the most probably used way of solving a quadratic equation is by solving by factoring. If you're going to solve a quadratic equation by factoring, first make sure that it is in proper quadratic form, which means everything is over on one side of the equation, it is set equal to 0. Once it's in proper quadratic form, you are ready to factor. Now there's many different factoring techniques, so the factoring could look different depending on the problem. So being familiar with factoring is very important. If you're a little bit weak on factoring, I would say maybe, pause this video, go back, maybe do some review on factoring. I've got many videos on that, on all sorts of different techniques, and maybe brush up on that because factoring is obviously going to be required for every single one of these since we are solving by factoring. Now, jumping right into the first example, example A, 9x squared plus 9x plus 2 is equal to 0. So we're going to solve this by factoring here. So whenever you approach a factoring problem, always check to see, is there a greatest common factor? Sometimes there is, sometimes there is not. This one does not have a GCF, so when it comes to factoring a trinomial where a leading coefficient is not a 1, I use what is called no-fuss factoring. No-fuss factoring is a four-step process that looks like this. Whatever your first term is, ignoring the exponent, write that down twice. 9x, 9x. That's step 1. Step 2, multiply your first number times the last number. 9 times 2 is 18. Give me a list of everything that multiplies to get 18, which is this list here. You're looking for what multiplies to get 18, but what adds or subtracts to get your middle number, which for us is going to be the 3 and the 6. Step 3 is your signs. If everything is positive in your equation, everything is positive in your signs. Step 4, the final step in factoring with no fuss, is you should reduce one or both of your factors. So think about reducing out a fraction. Out of 9 and a 3, we have a 3 in common, and we can divide that out, making that 3x plus 1. Over here, a 9 and a 6 also has a 3 in common, so divide out a 3 from that one, making it 3x plus 2. Once your equation is factored, you are ready to solve by using the zero factor property. The zero factor property says that you want to split your factors up, set them each equal to 0, and solve. I mean, think about it for a little bit here. We are claiming that this times this is equal to 0. The only way for this to be true, for this times this to equal 0, is if one of these has to be 0. Right? That's the only way you get 0 in multiplication. Now, mathematically, we really don't know which one of these actually equals 0, so we assume that they do both do. So we split the factors up. Let's separate them. We have 3x plus 1, and we have 3x plus 2. Set them each equal to 0 and solve both equations. So for this one, subtract 1 on each side, divide by 3, and we have x is equal to a negative 1/3. That is our first solution for this problem. Solve the second one, subtract that 2 on the other side, then divide out that 3, and we get that x is equal to a negative 2/3. So those are our two solutions for this quadratic equation. I'm going to leave the second example for you to try on your own, so I am going to move over to example C. Now, when we're looking at example C, first off, this is not in proper quadratic form. We need to put it in proper quadratic form. I just realized that there is a typo in this problem. This is the way that it is supposed to read. There was a plus sign previously. That's supposed to be an equal sign. Otherwise, we need to put this in proper quadratic form. Let's distribute the left-hand side to give us 2x squared minus 6x. Otherwise, the only other thing needed to put it in proper quadratic form is to move everything from the left side, move it over to the right side. So I am going to subtract 5x squared to the other side. So it'll cancel on the right, move to the left. And I'm also going to go ahead and add 7x to the other side as well. So I'm going to drop down the left what I had. We had the 2x squared minus 6x that we got after distributing. And then we moved over the 5x squared. We moved over the 7x. Set that equal to 0, and that is our equation in proper quadratic form. Now, we need to continue simplifying this because we should be seeing that we do have like terms here. 2x squared minus 5x squared is a negative 3x squared. Negative 6x plus 7x is a positive x. So this is the quadratic equation that we need to factor and solve. Taking a look at this equation, the only way that we can factor this equation is by factoring out a GCF. First off, if your leading coefficient is negative, the negative must be pulled out with your GCF. Otherwise, we don't have anything in common with our numbers here because we have a 3 and technically a 1 here. Otherwise, we do have an x here. We do have an x here. Remember, when it comes to factoring out x variables here, you want to take the one with the lowest exponent. We have x squared here, x here. 1 is smaller than 2, so we're only going to pull out one of the x's. So negative x is our GCF here. Factor that out to the front. Divide it out of our equation to see what belongs in the parentheses. When we divide, negative over negative cancels. Drop down that 3, and x squared over x is x. Different signs here makes that negative, and x over x cancels out to a 1. So this is how it factors. Once we have it in factored form, split and solve, split and solve. We have negative x, we'll set that equal to 0. We have 3x minus 1, and we'll set that equal to 0. On the left-hand side, divide out that negative, but we still are left with x is equal to 0. Remember, 0 is neither positive nor negative, so it is just a 0 there. For this one, we will add the 1 to the other side. We will then divide by the 3 to get that x is equal to 1/3 as our two solutions for this quadratic equation. A second way to solve quadratic equations is by using the square root property. So I'm going to go ahead and jump straight into this. The only really new concept thrown in with this section here is just understanding when we're solving an equation, if we want to get rid of an x squared, we would take a square root, since a square root and a square cancels. Just like if I had a square root of x, in order to get rid of a square root of x, I would want to square it, since when again a square root and a square do cancel with each other, leaving us with x. So that is the main concept to be understood with this little portion over here. So we are going to solve these 3 examples using that concept there. Jumping straight into example D. So the first thing that we're going to do in example D is divide each side by that 5. The 5s are going to cancel on the left, giving us x squared is equal to 9. Now, in order to get rid of a square, we take the square root. So taking the square root of each side, on the left-hand side, square root cancels with square, leaving us with x. On the right-hand side, square root of 9 is a plus or minus 3. Remember, quadratic equations should have 2 solutions almost every time, unless something different is going on with that example. A 3 times 3 gives us 9. Negative 3 times negative 3 also gives us 9. So plus or minus 3 there. Next example, the first thing we would do to solve this is get rid of that 3 there in front. Dividing each side, 3 is going to cancel on the left, leaving us with x plus 4 squared is equal to a 12. Next step is to get rid of that square. So once again, we're going to take the square root of each side. Square root and square cancel. We can drop down the x plus 4. On the right-hand side, square root of 12. So again, I always like simplifying radicals by hand. We can simplify radicals by hand by breaking them up into a multiplication using a perfect square. I have many videos on simplifying radicals if you need a refresher on that, if you need to pause this and maybe go brush up on that. Otherwise, the square root of 12, well, 12 is the same thing as 4 times 3. The square root of 4 is a 2, and we just drop down the square root of 3. That means the square root of 12 here is 2 square roots of 3. Last step here, well, actually, anytime we do take a square root, we do need to put a plus or minus in front of it. Remember, it's the positive and negative representation. So this would be a plus or minus 2 square roots of 3. Otherwise, last step is going to be to subtract that 4 on each side to get x by itself. X is equal to, proper form here, drop down your number first, radical behind it. So negative 4 plus or minus 2 square roots of 3. Our third example for this concept here, solving this example here, it looks like we can go straight to taking the square root on each side. Square root and square cancels on the left, and we can drop down to 3x minus 4 squared is equal to the square root of 8. If we simplify the square root of 8, we can break up 8 into 4 times 2. The square root of 4 is a 2. Drop down the square root of 2. So this means that the square root of 8 is 2 square roots of 2. I just realized that I wrote the squared here that's not supposed to be there. We took the square root of each side, and the square root and squared canceled. So this is just a 3x minus 4 on the left-hand side is equal to 2 square roots of 2. Finish solving this problem. Add 4 to the other side to get 3x is equal to number first, radical behind it, remembering to add the plus or minus in front of the square root. Otherwise, last step, divide each side by 3, giving us x is equal to 4 plus or minus 2 square roots of 2 over 3. The next process in solving quadratic equations is completing the square. First step in completing the square says that if your leading coefficient is not a 1, you want to divide the entire equation by that. In our first example here, our leading coefficient is a 1, so that's not going to apply. That will apply when we do this example right over here. Otherwise, when completing the square, the first thing we want to do is move our constant over to the other side. So we're going to take this 11 and add it to the other side. So our equation looks like this. We want to leave a blank right over here. Step 3 says to add 1/2 times b squared to each side of the equation. Now keep in mind that b just comes from your middle term in a quadratic equation. It is the coefficient of x to the first. So for us, b is a 6. So we're going to take half a 6 and we're going to square it. Half of 6 is 3, and 3 squared is 9. Add 9 to each side of your equation. Next step, we're going to factor the left side, simplify the right side. When we factor the left side, x times x gives us x squared. 3 times 3 gives us 9, and they do add to 6. Whatever sign the middle term has is the sign you are going to use here. So when you're using the process of completing the square and you're ready to factor, these should be the same exact factor. And because they are the same exact factor, we can group them together and call it x minus 3 squared. On the right-hand side, we can go ahead and add that up to get 20. Otherwise, finish solving the problem by the square root property, which is the process we just used in the last couple of examples. In order to get rid of the square, take the square root. On the left, the square root and square cancels, allowing us to drop down the x minus 3. On the right-hand side, square root of 20 could be broken down by taking 20 and changing it to 4 times 5. Square root of 4 is a 2. Square root of 5 just drops down. So the square root of 20 is 2 square roots of 5. Add that 3 to the other side, and x is equal to 3 plus or minus 2 square roots of 5. I'm going to hop over to this example here. You can test yourself with example H and see if you're able to do it. Otherwise, I am going to move on to example I that I have here. Notice that example I does have a coefficient that's not a 1. So what our steps here tell us to do, if a is not a 1, then divide the entire equation by a. So a is not a 1, so we're going to divide everything by a, which is a 3. 3 over 3 cancels, giving us x squared, minus, this is now 2/3 x, minus 2/3 is equal to 0. Next step tells us to move that constant over to the other side. So our constant is a 2/3. Move that over to the other side, giving us x squared minus 2/3 x is equal to a 2/3. We are going to add in that 1/2 b squared to each side here. So our b is a 2/3 for this example. So we're going to take half of that and square it. When we multiply this, 1 times 2, so let me just do that over here real quick. 1 times 2 is 2 over 2 times 3, which is a 6. But 2/6 can be reduced to a 1/3. All right, so this is really 1/3 squared. If we square that, well, 1/3 times 1/3 is a 1/9. So it is 1/9 that we are adding to each side of our equation there, which means the left-hand side is ready to factor. When we factor this, pay attention to this process here, because the factoring for completing the square is pretty much the same every single time we do it. Remember, we should be getting the same thing inside here, and this is how that works. X squared tells us x times x. Whatever sign the middle term has, it's going to be the sign for your set of parentheses every single time. Now we need to figure out what times what gives us 1/9, but adds to 2/3. A little hint here, going back over here to my work, I did my work specifically like this because it actually does help us out in this situation here. If you go one step up from your solution, the number inside the parentheses before you square, that is going to be the number that you plug inside here every single time. If you notice, the same thing worked over here. We got a 9 that we added to each side, but one step up, number inside the parentheses is the number that was used for factoring. That will work every time with this technique. So this is really just x minus 1/3 squared. That is going to equal, add these two fractions up on the right-hand side. We do need to get common denominators, so you can either work on getting common denominators like I just did. Again, common denominators are 9. Multiply the first fraction by 3 over 3, making this 7/9. Or throw that into your calculator. Otherwise, solve the remaining equation. Let's take the square root of each side. On the left side, square root and square cancels, and we drop down the x minus 1/3. On the right-hand side, instead of taking the square root of 7/9, it'll be the square root of 7 over the square root of 9. Now, the square root of 7 cannot be simplified, but the square root of 9 is a 3. Remember to throw that plus or minus in front. Otherwise, add the 1/3 to the other side to get us x is equal to, on the right-hand side here. So real quickly here, our number needs to be in front, our radical behind it. Do notice that they have the same denominators, so I'm going to go ahead and write them as a single fraction. This is just 1, our numerator from here, plus or minus the square root of 7 all over 3 for our two solutions. I just realized the video was not going as I was working out this first example here. The fourth technique is the quadratic formula. The quadratic formula is one of the most famous formulas known for solving quadratic equations. It's just a big order of operations problem where we take a, b, and c from our quadratic equation. Again, a for x squared, b the coefficient of x, c is our constant, in order to plug it into this formula. So for the first example, a is 1, b is 5, c is 2. Plug it in directly into the formula, making sure you put it in exactly as is. Dropping down the negative 5, 5 squared is 25, minus 4 times 1 times 2 is 8, all over 2 times 1 is a 2. Simplifying the subtraction here, 25 minus 8 gives us a 17. We cannot simplify the square root of 17, so that just got dropped down, leaving us with negative 5 plus or minus the square root of 17 over 2. Now, I'm going to leave example L for you to try on your own, so I am going to work example K, where A is 1, B is negative 6, C is a 10. So let's throw that into the formula. We get negative B plus or minus the square root of b squared minus 4ac all over 2a. Double negative rule here in front makes up the 6, plus or minus the square root of negative 6 times negative 6 is 36, minus 4 times 1 is 4, times 10 is a 40, all over 2 times 1, which is 2. Subtracting underneath here, well, 36 minus 40 gives us a negative 4. Taking the square root of a negative 4, when we do that, we're going to split this up to the square root of 4 and the square root of 1. The square root of 4 is a 2. Keep in mind that the square root of a negative 1 is an I. That gives us an imaginary number there. So when we simplify this here, this is 6 plus or minus. The square root of negative 4 is 2I over 2. Reduce this fraction. Everything is even, which means it's all divisible by 2. Divide everything by a 2, giving us a 3 here. Plus or minus 1I over 1, which we don't need to write. Our two solutions then are 3 plus or minus I.